Welcome to video lesson 7.4, Similarity in Right Triangles. We have 3 learning objectives for this lesson. The first one is identifying similar triangles which exist within another triangle. The second one is finding the geometric mean of 2 numbers. And the third one is using these 2 corollaries to find lengths within similar triangles. And I'm going to teach you a really cool method called the box method for that objective. So the first thing that we have here is a theorem telling us that when we have this right triangle with an altitude drawn in, so I have this new perpendicular created, then really what's happened is now I have 2 smaller right triangles which are going to all be similar to each other. So the large triangle is similar to the really small triangle, which is also similar to like that medium triangle there. And what results is 3 different similarity statements. So we're going to get some practice breaking these up. The best way that I think you should do this is by actually redrawing those pictures until you've figured it out pretty well. I'm going to redraw them all in that same orientation. So here my original triangle is X, Y, Z. Then I'm going to pick my medium triangle, which is this one right here. I'm going to redraw that, and I have Y, Z, W. And then my smallest triangle is going to be this one right here. My letters there are X, W, and Y. So what I've done is I've gone through and I've redrawn all those pictures with my right angle in the same spot so that they look similar, and then I go in and I put my letters in. Because now when I write my similarity statement, I'm just going to put triangle blah, similar triangle blah, triangle blah. Okay, so let's start all the way at the tip top and work our way around going through the right angle. So triangle X, Y, Z, similar to triangle. Y, W, Z, similar to triangle. X, W, Y. So I took each of these triangles, which I've now drawn the same way. I start at the top, go through the right angle, and then to the other side. Each one I did the same way. So then I have a you-try problem for you. Please do that and show me your answer in class. The next thing we're going to look at is finding the geometric mean between 2 numbers. So we first need to know what this is. Geometric mean between any 2 positive numbers is the variable x such that a over x equals x over b. Okay, and if you remember when we learned about proportions in the first place, we said these 2 things were called our extremes because they were on the far ends, and then these things in the middle were called the means. Okay, so that totally makes sense. This helps us find our geometric mean. We put in the letter x, we substitute in our 2 different numbers, a and b, and then we're going to solve by cross multiplication. So the first example here, if I want the geometric mean between 6 and 15, I say, okay, so 6 over x equals x over 15. I'm going to cross multiply, which gets me x squared equals 90. I take the square root of both sides, and I get x equals, oh boy, that's going to be a decimal. If I look at square root 90, when I put that in my calculator, I get 9.486832, blah, 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 blah. I don't want that as my answer. That's no good to me. And I also know that on the end of course exam, I cannot enter a square root. So this is probably going to be like a multiple choice question. This answer here is not simplified, so it's not ideal. What I need to do is I need to simplify this radical. Now, some of you may be able to do this fairly quickly, but for the others, I want to remind you of how to do this. I'm going to show you a method that I call Joe's method, because one of my students, who is from Brazil, taught me how to simplify radicals this way, and it's a really nice, neat, organized way. A lot of people use factor trees, and this essentially does the same thing, but it's really, really organized. So what I'm going to do is I'm going to take 90, and I'm going to draw a vertical line down next to it on the right, and I'm going to start breaking 90 down. First, I'm going to try to divide by 2 because that's my smallest prime number other than 1. Then I'm going to try to divide by 3. Then 5. If I need to, then 7. Okay. So let's start with this one. 90. Is it divisible by 2? Yes, it is. So what I do is I write a 2 on the right, so I remember that's what I divided by, and then I divide. 90 divided by 2 is 45. Okay, again, I ask myself, is 45 divisible by 2? No, it's not. So because now it's not divisible by 2, I'm done dividing by 2. I need to move on to divide by 3. 45 divided by 3, yes, that works. I get 15. I ask myself again, can I divide by 3 again? Yes, I can. 15 divided by 3 gets me 5. I ask myself again, can I divide by 3? No. So I move on. Can I divide by 5? Oh, yeah, I can. I get 1. As soon as you get down to 1, please put a box around that number. That's always where we want to get. We always want to break a number down, putting our factors on the right and whatever we got when we divided on the left, and we always want to get down to 1. Now what happens is, since this is a square root, I'm looking for groups of 2 that can come outside of my square root. So on the right-hand side, I look at all my factors, and I ask myself if I have 2 of the same number. I do. I have these 2 3s, so I'm going to circle those up. And what that tells me is that a group of 3s gets to come out. Now, I just said a group, so a group of 3s gets to come out. And the people left inside are this 2 and this 5. We multiply 2 times 5, and that's what's left underneath our radical. Now, some of you may have been able to recognize at the very beginning, because you remembered how to do this, that 9 times 10 is 90, and the square root of 9 is 3. So the 10 stays under. Some of you may have recognized that. Otherwise, please go ahead and feel free to use this Joe's method. Please complete the you try. Show me that in class. So now I want to show you these 2, they're corollaries, okay? Basically, it's like patterns for our proportions that exist within these triangles. So each of these pictures is one of those right triangle things where I have the altitude drawn in. And they provide me with 2 different ratios that I can set up, which will always, always hold. So I want you to put these into your notes. If you're somebody who's really good at memorizing patterns, you can go ahead and use these and just kind of simply memorize how they work. If I have this ratio here, AD, so let's see, that's the small piece here, so my small piece here, over my altitude is my long piece. So small over altitude equals altitude over large. That's one of the patterns. Down here in the second example, we've got small over my side equals my side over my whole length. If you want to go ahead and memorize these, that's totally fine. On the next slide, I'm going to show you something called the box method. But here, I'm going to show you at least how to set this up. So let me shrink down this slide real fast. Put that off to the side. And I'm going to show you how to draw this box. Need one more. Okay, so you need 4 lines going across and 4 lines going down. This creates a box for us that we're going to use. And we need to label our 2 like axes almost, kind of like our X and our Y axes, except we're labeling to set up this grid. So in the top, I'm always going to be talking about which triangles I have in my picture. And I know in each of those pictures, we had the really big triangle, and then we had the 2 smaller ones. So we're going to call them the small, the medium, and the large triangles. Again, the small, the medium, and the large triangles. Now, along the other side, we need to be talking about the side lengths. So here, we're going to have the hypotenuse. So I'm going to write HYP for hypotenuse. And then we have our big side and our tiny side. So for triangles, we have small, medium, large. And for sides, we have the hypotenuse, the big side, and the tiny side. And then we're going to start filling information into this grid when we're given an example. So I'll show you that next slide. Okay, so here's the example I'm going to do for you. I'm going to create that chart again. Go ahead and try to create that chart. Okay, so remember, my triangles go on top, small, medium, large, and on the side, I have my hypotenuse, my big side, and my tiny side. Now, what I need to do is I need to look inside of my picture and start filling out the information that they've given me. If you look at the picture, they've given me 4 values. 2 of them are numbers, 2 of them are variables. So I'm going to look at each triangle on its own and fill in this chart. So I'm going to focus in on the small triangle. Here's my small triangle. My hypotenuse, remember, is the side across from my 90-degree angle. So here's my 90-degree angle, which means my hypotenuse is x. So in my chart, hypotenuse, x. Now I also know that in that triangle, my big side, this one here, is y, and my tiny side is 4. My big side is y, my tiny side is 4. So I fill in all of that information. Now I move on to my medium triangle. So here's my medium triangle. This is my hypotenuse, and I don't know the length. So it's okay to leave blanks in this grid. I'm not going to have all of the information, so I'm going to have some empty squares. My big side is 12, and my tiny side is y. Big side is 12, tiny side is y. And then I move on to my large triangle, which is this one here. My hypotenuse is this whole length. So not only is it 4 and 12, but it's actually the whole 16. So for my large triangle, my hypotenuse is 16. My big side, I don't know, but I do know that my tiny side is 4. Okay, so beautiful. I've set this thing up. Oh, hold on. Go back. My tiny side is not 4. I wrote that. I did not mean that. My tiny side is this one right here. It's x. I don't know what the heck I was thinking. Okay, so x. Okay, so now that I've got this chart, what I need to do is I need to actually find out my values of x and y. What's awesome is when I look at this, I kind of just like see the actual proportions just pop out at me. Like if I'm trying to solve y, here's a y and here's a y. So look at this little box right here. I can actually just go ahead and set that up as a proportion and I can solve. So let's see. I'm going to take up the space for the u try, but y over 4 equals 12 over y. So all I did is I had to find this little box that told me my proportion. So now I go ahead and I have cross multiplication. So y squared equals 48. Take the square root, take the square root. Okay, again, this is going to have to be something I simplify. So I'm going to take the 48. I'm going to draw a line down to the right of it. So you can practice your Joe's method here. 48, is it divisible by 2? Yes. That gets me 24. Is it divisible by 2? Yes. That gets me 12. Is it divisible by 2? Yes. That gets me 6. Is it divisible by 2? Yes. That gets me 3. Is that divisible by 2? No. But it is divisible by 3, which gets me down to my 1. Okay, so now I'm looking for groups of 2. So this is a good example for you because now, in that last example, I could only circle up one group of 3s. Here, I can circle up this group of 2s and this group of 2s. So what that means is I can take out not only 2, but I can take out 2 times 2, which means I'm pulling out a 4, and under the radical is my 3. So I know that y equals 4 radical 3. And I have to go back and I have to find x. So I'm looking for my x's, x, 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 x. Oh, look, I also have some other values in these rows that would pop out and be a proportion for me. Ignore this information about y. I don't really care about the information regarding y. So what I have left is x over 4 equals 16 over x. So let me shrink up this page a little bit. We're going to go ahead and do that math. So I have x over 4 equals 16 over x. When I cross multiply, I get x squared equals 64. I take the square root of that to solve, and I'm left with x equals 8. Okay, so x came out really nice. Y ended up being a radical that I had to reduce, but I was able to find my x and my y, and I didn't have to memorize those corollaries because it gets kind of confusing when I have a lot of information given to me. So remember, we set up this box with small, medium, large, and hypotenuse, big side, tiny side. Then we fill in our information. Whatever we have, we put in. Whatever we don't have, we just simply leave blank. Then I crossed out my y's, and really I shouldn't have crossed out this 12. I could have used that, but it didn't really help me because I'm looking for things that are in the same column as my x. Here, my y and my 4 were together, my 12 and my y were together. That's what I ended up using. For my x, I didn't want to use y, so those were gone, and I needed something in the same column, which left me with x over 4 and 16 over x being equal. So you see this proportion, this nice proportion, pop up for us. All right, so please make sure that you have all of these examples in your notes and you have all of these you tries in your notes, and I will see you in class.